Hi, wishing you all. I'm Dr. J. Roy, Associate Professor of Physics, Institute of Aeronautical Engineering. So today I wish to tell about the topic lasing action, components and types of lasers. That is, lasing action, how the light will be amplified. So lasing action, and then components of lasers. After that, we move to the types of lasers. So here we are going to cover these topics: lasing action, construction and components of a laser. So how the laser is constructed and what are the components we use in the lasers. Then types of lasers. So there are so many number of lasers are there. So in that we are going to see about a solid state laser, gas laser, and then semiconductor laser. Lasing action. So after completion of lifetime of electrons in the metastable state, they fall back to the lower energy state or ground state by releasing energy in the form of photons. So this process of emission is called spontaneous emission. Already we have discussed in the previous sessions. So after completion of lifetime of electrons, that is a lifetime of an electrons is 10 power minus 8 seconds. So lifetime of an electron at the excited energy state is 10 power minus 8 seconds. So after completion of 10 power minus 8 seconds, the electron which is in the metastable state, they fall back to the lower energy state or ground state by releasing energy in the form of photons. So this process of emission of radiation is called spontaneous emission. When this emitted photon, that is the emitted photon through the process of spontaneous emission interacts with the electron in the metastable state. So it forces that electron to fall back to the ground state. So as a result, two photons are emitted because that emitted photon, this emitted photon by the spontaneous emission, it forces that electron to fall back to the ground state. So that stimulated emission occurs here so that two photons are emitted. So this process is stimulated emission of radiation. So already we have seen that. So when the electron is at the excited state E2, E1 is the lower energy state, ground state. So before the lifetime of an atom, the electron gets stimulated with some radiation, transits to lower energy state by emitting two photons. So this process is stimulated emission of radiation. When this emitted photon through the spontaneous emission interacts with the electron in the metastable state. So metastable state is the state at which the electrons are having longer lifetime. So it is the metastable state is readily available in the impurity atoms of a crystal. So here emitted photon interacts with the electron in the metastable state. It forces that electron to fall back to the ground state. So because of this, two photons are emitted. So this process of emission is called stimulated emission. When these photons again interacted, so these two photons which are emitted by the stimulated emission again interacted with the electrons in the metastable state. So they forces two metastable state electrons because two emitted photons interacts with the electrons in the metastable state, so that two metastable state electrons fall back to the ground state. So because of that, four photons are emitted. Four photons are emitted. So likewise, a large number of photons are emitted. As a result, millions of photons are emitted by using small number of photons. So in the first case, here in the spontaneous emission, after the lifetime of an electron in the higher energy state, spontaneously comes to or transits to lower energy level by releasing photon. So this emitted photon interacts with the electron in the metastable state, so that the electron fall back to the ground state. While it is fall back to the ground state, it emits two photons. So these two photons interact with the electron in the metastable state again. Then these electrons, while fall back to the ground state, it emits four photons. Four photons. So likewise, stimulated emissions occurs. So a large number of photons are emitted. So in this way, millions of photons are emitted by using small number of photons. So 1 to 2, 2 to 4, 4 to 4 into. So we are getting likewise more number of millions of photons be emitted by using small number of photons. Next, coming to the construction and components of a laser. So any laser system consists of three components. Whatever the laser system we may take, it consists of three important components. One is source of energy. Source of energy. Next one, active medium. And then optical cavity or resonator or optical resonator. We can say also optical cavity or optical resonator. Optical cavity or optical resonator. Let we see the source of energy. To get laser emission, first we must have population inversion in the system. So what is the population inversion? Let's recall here. Usually at a normal condition, the lower energy level have more number of atoms compared to the higher energy level. So let E1 is the lower energy level, E2 is the higher energy level, and N1 is the number of atoms per unit volume in the energy level E1. N2 is the number of atoms per unit volume at the energy level E2, then at normal conditions, that is in general conditions, N1 is greater than N2. Number of atoms in the lower energy level is greater than the number of atoms in the higher energy level. So that comparing to the higher energy level, the lower energy level atoms are more. This is at normal conditions, that is at equilibrium state. N1 is greater than N2. We are talking about number of atoms in the energy levels. So population inversion. So if this condition is inverted, we can say population inversion. Population inversion. So the population, in the case of population inversion, N2 is greater than N1. Then we can say that there is population inversion. So we have to make it, this N1 is greater than N2 to the condition of N2 is greater than N1. So in general condition, there is more number of atoms at the lower energy level comparing to the higher energy level. So that N1 is greater than N2. N1 is greater than N2. So making N2 is greater than N1 means how it would be. So E2, E1, N1, N2. So wanted to make this situation to this situation. So from this condition to this condition, which what condition here? Here when seeing this diagram, we can easily identify that more number of atoms are in the higher energy level. So number of atoms in the higher energy level is greater than number of atoms in the lower energy level. And making this condition is called population inversion. That is making more number of atoms in the higher energy state comparing to the lower energy state is called population inversion. It's called population inversion. So to get the laser emission, we must have population inversion in that system. So the source of energy supplies sufficient amount of energy to the active medium, by which the atoms or molecules in it can be excited to the higher energy level. So here we are going to supply some energy, sufficient energy. So to which we are supplying energy? We are supplying energy to the active medium so that the atoms or molecules can be excited or stimulated. They get stimulated so that they transits to higher energy levels. So to get laser emission, there should be population inversion. So and then source of energy, when supplying source of energy to the active medium, so atoms or molecules get excited to the higher energy level. So resulting to that, we get a population inversion in an active medium. That means source of energy supplies energy, and When supplying that energy, it pumps the atoms or molecules in active medium to excited state. Active medium to excited state. So that we are going to achieve the population inversion. To achieve the population inversion, we have to supply some energy, sufficient energy to the active medium so that atoms or molecules can be excited to the higher energy levels. So that the atoms in the higher energy level be more compared to the lower energy level. So population inversion takes place in that active medium. Okay, because source of energy supply energy, source of energy supply energy to the atoms or molecules, and then it pumps the atoms or molecules in the active medium excited and go to the higher energy states. And then active medium, the second component is active medium. So this is the medium where stimulated emission of radiation takes place. Where the stimulated emission of radiation takes place is the active medium. After receiving energy from the source, after receiving the energy from the source, the atoms or molecules get excited to higher energy levels. While transiting to lower energy level, the emitted photons start the stimulated emission process, which result in laser emission. So depending upon the type of active medium, we may have solid state laser, liquid state laser, gaseous state laser, and semiconductor lasers. So what is the role of the component active medium? So in this active medium only, the stimulated emission of radiation takes place. How the stimulated emission of radiation takes place? In the previous one, source of energy, the component of source of energy. So by the source of energy, we are supplying sufficient amount of energy to the active medium so that atoms or molecules get excited to the higher energy levels. So after they excite to the higher energy levels, then they transits to the lower energy levels by emitting photons. So this emitted photons triggers, or this emitted photon interacts with the electrons at the metastable state so that they fall back to the ground state. While it is falling down, it emits photons. So while transiting to the lower energy level, the emitted photons start the stimulated emission process, resulting laser emission. So depending upon the type of active medium, we may have different types of lasers: solid state laser, liquid state laser, gaseous, and semiconductor lasers. These semiconductor lasers are also called as a diode lasers. Optical cavity or optical resonator. The active medium is enclosed between a fully reflective and a partially reflective mirrors. So active medium is enclosed between a fully reflective and a partially reflective mirrors. So these two mirrors constitute an optical cavity or optical resonator. So what is the purpose of this optical cavity or optical resonator? This reflecting portion of mirrors reflect the incident photons back into the active medium. So these reflected radiations enhance the stimulated emission process within the active medium. This reflected radiation enhances the stimulated emission process within the active medium. As a result, we get high intensity, monochromatic and coherent laser light through the non-reflecting portion of the mirror. To the non-reflecting portion of the mirror. So here you can see that components of a laser. This is pump source. Pump source. So pump source is nothing but source of energy. Source of energy. So by giving sufficient amount of energy to the active medium, to the active medium, to the active medium. So here in this active medium, the atoms get excited to the higher energy state. So pumping process B happens when we are giving source of energy. And then there is an active medium here. So where the stimulated emissions takes place. So through the source of energy, the atoms in the the atoms in the active medium get excited. So when these atoms excited to higher state, then when they fall back to the ground state, they emit photons. So these photons interact with other electrons in the metastable state. Then when it fall back, so again it emits photons. So likewise, the emitted photons be multiplied. So more number of photons be emitted. So stimulated emission takes place in the active medium. In this active medium, that is lasing medium or active medium. And then the component optical cavity or optical resonance. This is optical cavity or optical resonance. Optical cavity or optical resonance. Okay, so this system consists with two reflective mirrors. That is, this one is a highly reflective mirror, and this side is partially reflective mirror. So when the photons are emitted by the lasing action, the photons get moves through and forth, back and forth, in between this reflecting and partially reflective mirror, and it gets multiplied. After that, the at high intensity they come out from the partially reflective mirror. So active medium is enclosed between the fully reflective and partially reflective mirrors. So these mirrors constitute optical cavity or optical resonator. So the reflecting portion of mirrors reflect the incident photons back and forth into the active medium. So these reflected radiation enhance the stimulated emission process within the active medium. So as a result, we'll get high intensity monochromatic and coherent laser light through the non-reflecting portion or partially reflecting portion of partially not non-reflecting partially reflecting. So as a result, we may get high intensity monochromatic and coherent laser light through the partially reflective mirror. Partial reflecting portion of the mirror. So here it constitute the active medium constitute with two reflecting mirrors. So these two mirrors reflects the photons back and forth, and finally we'll get at high intensity coherent monochromatic light through the partially reflective mirror. Radiation come out from the partially reflective mirror. Next, types of lasers. So there are many number of types. So there are many types of laser systems available. In that we are going to see mainly solid state laser, gas laser, and then semiconductor laser. So solid state laser, the solid state laser have lasing material distributed in a solid matrix. Distributed in a solid matrix. For example, the ruby laser. Ruby laser is the first solid state laser. Okay, so the ruby laser or neodymium, yttrium, aluminum, garnet laser. So ruby laser emits 6943 angstroms, whereas neodymium, yttrium, aluminum, garnet laser emits infrared light of 1.064 micrometers. In the gas lasers, they have lasing material helium neon or CO2. In this helium neon laser, HENE laser, it emits 6943 angstroms, whereas CO2 laser, it emits energy in the far infrared 10.6 micrometers and are used for cutting hard materials and for some medical purposes. Coming to the semiconductor laser. So semiconductor laser, sometimes called as a diode laser. They are not solid state laser. They are not solid state laser. They are different from the solid state laser. These electronic devices are generally very small and use low power. They may be built into small arrays. For example, they can be used as writing source in some laser printers or compact disc players. So these are the type of lasers which we use mainly. Okay. In the next session, we shall discuss about the ruby laser and the helium neon laser. So ruby laser belongs to solid state laser. Helium neon laser belongs to the gaseous laser. So ruby laser is the first solid state laser which was invented by the Neumann. So in this ruby laser there is some drawbacks, so that we are going to the further type of lasers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.